So we are given a function g, and we have to, g is a differential function, and we have to derive that d by dx of 1 over gx is minus g prime x upon gx whole square. Note that g prime of x is d by dx of gx. Now we'll just use the standard machinery, which is, I beg your pardon, d by dx of any function fx is limit of h tending to 0 f of x plus h minus fx upon h. Note that I'm just not writing in terms of left hand limit. This is actually right hand side limit, but we can do both and it will turn out to be same. So just for brevity, I'm writing the right hand limit only. Now consider fx to be equal to 1 over gx. Therefore d by dx of 1 over gx, and note that this is exactly what we want to have on the left hand side of the equation. This will be equal to limit h tending to 0. Now I substitute 1 over gx here in this equation. This will be 1 over gx plus h minus 1 over g of x whole divided by h. Now I do cross multiplication, so this will be limit h tending to 0 g of x minus g of x plus h upon g of x plus h. Okay, now I'll come and write here. So simplifying this, note that a by, so this is of the form a divided by b divided by c, and we know that this is equal to a divided by b times c. Okay, so let me get the same color. Again, this expression now simplifies to limit of h tending to 0 g of x minus g of x plus h. And let me write it differently. Note that this, I can remove this division divider line here and put h here, and I'll write this little differently. I'll write this h times 1 over gx and g of x plus h. Okay, now note that gx is constant when I'm considering the limit of h tending to 0. Okay, let me put it this way. Call this function, say a1 of x, call this function a2 of x. So what we are dealing with is limit of h tending to 0 of a1x by a2x, and we know that we can now write it as limit of the numerator by denominator, so g of x minus g of x plus h by h whole divided by limit of h tending to 0 gx and gx plus h. Now the uppermost quantity is minus sign of g prime of x, right? Because this is nothing but negative of d by dx of gx, and the quantity which is below in the denominator, it's limit h tending to 0 of gx and gx plus h. So this is same as limit of gx times limit of gx plus h. Gx remains as it is, and limit of h tending to 0 of gx plus h is nothing but gx, because g is a differential function, so it is also continuous. Hence limit of h tending to 0 of gx plus h is nothing but value of g at that point x. This follows due to continuity, and continuity follows because g is differentiable. Hence, as a result of this, we get the expression minus g prime of x upon gx whole square, and this is exactly what we wanted to prove, hence we have proved.